I got to record. So now I'm officially back. Hello, everybody. It's not Happy Garbage Day today because we had President's Day yesterday, and so the garbage is all off a day. So just Happy Tuesday. My watch tells me it's 55 degrees outside in February, so that's happiness for Iowa. That's what it gets. So I wanted to start off with some announcements and recommendation type things. So number one is that I believe I told you sometime, maybe Monday, your next homework is available. And as it's noted on the online syllabus in the printable version, I gave you 2 extra days because we're not all the way through example 2A yet. So I wanted to make sure you have a full week. However, you can do all of it right now. It's the very last model that would require anything involving an interaction term, but the rules of it and the processes are exactly the same as in regular linear models. There's nothing different about it because we're in Logit land, but I do want to show you that example, so that's why I pushed it back. So you have that to be working on. Formative assessment 2 we're going to talk about today, so that's the first item up for bids. I also wanted to remind you of the resources that you have in terms of personnel. So the TAs, and I've been discussing this, and I want to tell you a little bit of background. I don't know how to use TAs very much because I've never had them. I started at a tenure track job in 2006 at the University of Nebraska-Lincoln in the Department of Psychology. I was there for 8 years. I never had a TA. All of the TAs went to the undergraduate courses, which were much larger, and that made a lot of sense, and I didn't even think about it. I then transitioned to the University of Kansas. I was there for 4.5 years, and in my very last semester, I finally got a TA because the person that they were supposed to TA for quit unexpectedly, and there was no class to TA. So I got that person, who happens to be Jihong Zhang, a recent graduate of our program and now in the tenure track himself. So full circle. So when I first started teaching here, I've been here 5 years, I didn't have TAs either. And then within the last couple of years, I've gotten some, in part because of funding within the department, but also folks who are taking it for course credit and teaching experience. So I'm new at being able to figure out how to effectively use these resources. I know the one thing that they cannot do, and I will not ask them to do, is to grade you or otherwise formally evaluate you in any fashion. That's all on me. That's the only ethical way to do it, given that most of you are friends and peers and all of that kind of stuff. But otherwise, all 3 of us are here to help you. So I want to remind folks about office hours. Bladimir's are Tuesdays and Thursdays in the morning from 9 to noon. Nikki's are Monday, 8:30 to 10 for the early risers. On Fridays, 10 to 11:30 for not so early risers. Mine are for the late risers, Monday and Wednesday afternoons from 3 to 4:30. These office hours are yours to use in whatever way makes the most sense to you. If you want to just come, hang out, work on your homework, even if you don't have a question yet, just so that you have a little bit of company and some structure, and then pop in, when you need to, like ask questions and then go back working, that's totally fine. And I know it's distracting to hear other people talking. You can turn your audio off and send me a chat when you want me, and we can make that aspect of it work. If you want to just go over concepts, like you'd like to review some things, ask some questions, things like, can I tell it to you in my own words and you tell me if I'm right? Like those kinds of check-ins can be very useful. So I want to encourage you to feel like you can ask for help. Another thing that we're going to start doing as soon as, so Nikki's getting set up here. Bladimir's already in the Zoom room, even though he's in class. I want to, there she goes. I want to encourage you to send questions from Zoom to the TAs during class if you're feeling shy. You can direct message them or me. I've got the chat here. I try to keep an eye on it as best I can. And if you don't feel comfortable asking a question, send it to them and they can either answer or they can verbalize it so that we can all talk about it together. If you want me to slow down and you feel sorry, like don't want to say that out loud, tell them to make me slow down. I'd like to introduce like a hand gesture, like just do this. And that means take it down a notch, Lisa. I've got 7 up here. I don't even have caffeine. This is just natural enthusiasm right now. But I know that I can talk fast or go too fast. So if I need to slow down, if you want me to repeat things, anything that would help your learning. So those are the personnel resources. I wanted to remind folks that within YouTube, of course, the videos have closed captioning. It's not perfect, but it's better than nothing. And if you, within each of these videos, if you go down to the description here, there is a link to a transcript, okay? And that will show up over here. You can print it, you can save it, and you can search it. Okay, so Control F, like homework question, right? If I did something about homework in that class, it will take you exactly to where in the video I said that thing. So this is an interactive way to review things that happen during class as needed. If you want to, outside of class, you have access to us via office hours and email. Okay? All right. And just from an educator's perspective, when I ask questions in class, you can see my YouTube rabbit hole here. I'm very excited to watch Jon Stewart tonight. I'm looking forward to that. We always watch the late night shows the next night after dinner while my son eats his dessert in front of his iPad, which takes no less than an hour. Because, you're not focused on what you're doing when you're sitting in front of an iPad. But I use that to my advantage. What I wanted to say is that when I ask questions, I know folks are sometimes hesitant to respond. Wrong answers are good. I know you may not believe me, but honestly, if you can say something wrong, then at least I know where the misconception is and I can try to work with it. Or answers like, I think this is wrong, but I'm not sure why. Like that is an opportunity to clarify. So don't feel like you're going to be viewed as inadequate or inferior if you answer wrong questions. What I can't work with very effectively is silence. Like I can't intervene if I don't know what's wrong. So just please, I take this job very seriously. The reason that I got into this career was to become a teacher, honestly. I thought I was going to be a statistical consultant, go crank analyses for people. And then I got my first chance to teach as a postdoc. And it changed my life. So after that, I was like, I'm going to go teach advanced quantitative methods. I'm going to fake a research program long enough to get tenure. And I did it, and I'm still doing it. So please, I'm begging you, okay? Let us help you because you're all here for a reason. You're all capable, and you can all do this. So my TAs are here because they want to gain teaching experience. And at least within the EMS program, that is hard to come by. We don't have classes that are where you can be the instructor of record. So I am going to implement a suggestion that someone from the clustered multi-level class gave me last fall, which is to let the TAs start leading formative assessments so they can get a chance to talk. So if you would all like to come up here, I am going to camp over there so that I'm still within earshot of the microphone in case I want to interject. But I've got the questions that you all answered here. Nikki's scheduled to take the first two, and Bladimir is scheduled to take the last two. Yeah, so make sure you're in the camera frame. There we go.
Hi, Zoomers.
And watch the chat.
Great.
Watch the chat while you watch their faces. That's my only piece of advice.
Okay. This is a new phenomenon. Yes, I'm used to like in-person stuff, so I'm excited.
Welcome to hybrid.
Yeah. We'll see if I like it. But okay, so formative assessment, we had 4 questions. I'm taking the lead on the first 2. And so the first question from the formative assessment was what problems would be created by predicting a binary outcome using a standard general linear model? I looked at the answers this morning, and you all had excellent responses to this question. So what do folks think?
First issue that comes to mind is if we use a standard linear model, then we are predicting for every value of x. When we have binary outcomes, we only have 2 possible outcomes. So all of those in-between values we're predicting don't make sense in context.
Excellent. So we have this problem of boundaries, essentially. And what Sergio was talking about is that a standard linear model will predict outside of what is possible within our outcomes. So we have essentially a boundary issue is the way we talk about it, which is what a lot of you wrote in your formative assessments. So great job on that one. Lisa, do you want to add anything about the first point?
Yes. There's another problem still that we have to.
Well, yeah, that's why I'm like the first one.
I think that predicting between 0 and 1 makes sense if you think about the conditional mean of what you're predicting and probability. So what you're trying to predict is the probability of having a 1, as that's what the model's focusing on. But in doing so, you would not understand that probability has to stop at 0 and stop at 1. So it's the boundary issue is one problem.
Do you have your slides up with that picture or no?
Maybe. Did I get them up in time? Okay.
No.
Yeah. No, yeah, here we go. It's, yeah.
Ooh,
I just saw it.
this one right here.
7. There it is.
Yeah, so what Lisa was saying essentially here is the model, if we're predicting what the probability would be, values between predicting 0 and 1 are real values. And then it's the problem when we go above 1 and below 0, essentially. And so the idea is we have a model that kind of accounts for that. And as you get closer and closer to 1, it just asymptotically approaches 1, which just means it gets really close to 1. And 0 on the bottom end. Great.
I have a question.
Yeah.
What Lisa just said, there was a term like conditional mean.
Mm-hmm.
So I got the concept of the range from 0 to 1, like bounded, but I don't really get what conditional mean.
Yeah. So this kind of comes up in the context of the second question of kind of like what's going on underneath the hood, essentially, when we use a link function and whatnot. And so that's where it comes into what's being predicted is the conditional mean. So in a sample, if we have a certain proportions of 1 and a certain proportions of 0, we're essentially predicting that proportion, which would be the probability. When we don't have any predictors in the model, our best guess is what the overall sample is. What would you like to add?
We're always predicting the mean, right? So if you think of an empty model, like the intercept is the mean, right? And then if you add a binary predictor, you get the mean for this group, the mean for that group. And then as you add another predictor, like you customize the means, but they're still the means in the sense that they would be the same for everybody with that predictor pattern. And so the mean of a binary variable is the proportion of ones. So that's what we're trying to get at. For any case, what is the probability that you have a 1 instead of a 0?
I have one question now that you're talking about that, because yesterday I was thinking about this specifically about this idea of the expected value or the conditional mean. So in the distributions, most of the time, what we model is the mean, right? However, I remember that we also have this idea of quantile regression, where we can model, instead of the mean, one of the quantiles from our variable.
That's unit 4.
So my question is, well, it was because, why? Why the mean? That was my question too. Why the mean instead of other thing? But now that you mention what you mentioned makes sense. So that's interesting. Exactly. Yes. So that this idea of expected value doesn't mean necessarily the mean of the distribution. The expected value is the thing that we are modeling, right? Conditional on our predictor. So that's interesting. Thank you.
Mm-hmm.
Go on, please.
But I think in the formative assessment, we were talking specifically about binary outcomes. So you're doing teasers for advanced units.
No, because I had the same question yesterday and I was trying to answer myself. Why?
Great. Okay, so we talked about the first issue, essentially, of this boundary issue. There was a second issue that some of you talked about.
But not many.
Yeah, but not many. Yes. Yep. Yeah, so there's actually 2 issues with the variance. And it's the variance of the residuals, right? So it's kind of like the leftover. So the first issue,
It's like 2 slides from now.
Great. Cool.
It's hard to be put
This
on the
one.
spot, isn't it?
Yes.
Oh, I know that. I had no doubt about that. But the idea is when we have a binary predictor, you are either a 1 or a 0. So if we thought about what residuals in theory could be, you're either going to be a 0 or a 1, kind of, you're going to be negative 1 or 0 or positive 1, whatever. It can only be one thing, which means that your residuals are not normally distributed, which is a violation of just standard linear regression. So that's problem 1A. And then you also talked about your variance isn't constant. So again, we're talking about just predicting a binary outcome here. So this might be different in quantile regression, but the idea here is that mean and variance is dependent upon each other when you have just a 1 or 0 outcome. So they're essentially coupled together, which means that your variance is going to look different depending on what your value is in your sample.
And I'm just realizing this is the version where my equations went insane. So I might have to pull up the PDF instead.
Yeah.
Use this I don't know why.
The idea down here, though, I think this table is still helpful in understanding what Sergio was talking about in terms of variance looking different depending on what your value of your conditional mean is. Great. Do you want to add anything about the second one? Okay. Are there any questions? Standard errors.
Like the variance not being constant affects the standard errors, right?
Yep.
They need to stretch and shrink as you move closer to the boundaries.
Yep. And then standard errors being wrong translate to your p-values then, and significant tests being wrong. Yep. Excellent. Okay, any questions about the first formative assessment question? Yeah.
The dual monitor setup is tricky. Non-constant variance, yes. That means the bottom of this right here. It's the biggest in the middle and it shrinks as you go to the side. So, and yeah, I'm gonna have to, that ain't gonna work very well. Here you go.
Great. Excellent. Okay, so then the second question we have is, in general, what is the purpose of a link function? And how would you know that you might need to use a link function in the first place? So let's start with, what's the purpose of a link function? Yes. Yep, so the idea here is that we're predicting the conditional mean, and we want to transform it such that we kind of account for that boundary issue that we were talking about in the first formative assessment question. I have a bonus question that wasn't on the formative assessment. If we want to go, so a link transformed, you go from the model scale, am I doing this right? Model scale to link transformed. If we want to go the other way from link transformed back to our data scale, what's that called? What was that? You can call a friend. I'm not going to call on you. It starts with an I. It starts with an I. Inverse link. Yep. So link is going from data to transformation. Inverse link is going from transformation back to your data scale. Great. Okay, so then the second, do you want to add anything?
The words people use is model scale and data scale. So to go from data scale to model scale is the link. To come back down from model to data is inverse.
Great. Nikki language is apparently not that.
Yes,
absolutely, absolutely. Great. So how do we know we need to use a link function? Yeah, so if you have a boundary, a variable that has boundaries, there we go. Absolutely. More generally, it's, what was that? Great, yes, absolutely. If you don't have continuous, absolutely. So to account for the boundaries, absolutely. So a bonus question, what are some types of outcomes, right? So the non-continuous one, what are some examples that we've been talking about in this class? Binary, yeah, excellent, great.
What's coming up later?
Yep. Ordinal, yep. And then there's another one that we haven't talked about as much. Starts with an N. Nominal, yeah. Great job, everybody. Do you want to add anything about?
Later on, count.
Oh, yes.
Things that are bounded at 0 and skew, so they're sort of continue-ish, I call them.
Yes.
That's coming up.
Great. All right, I'm going to hand it off to Bladimir. Yeah.
What are things that would be, like, what are examples of things that are continuous versus something that's not continuous?
Yeah. So in my work, very often we model like student success. And so we could think of that as like GPA. That's often continue-ish enough for our purposes. It does, though, have a boundary at 0 and 4. So a more appropriate model would be accounting for those two things. You can, I'm trying to think in my work.
There's nothing that's actually continuous that we would ever look at. But it's continuous enough if it's far enough away from the boundaries that we're not worried about the predictions going out of bounds. So like response time is a truly continuous measure, like to the millisecond. Response time is bounded at 0, but most tasks are not going to get anywhere near 0. Right?
Yeah.
So there's really nothing that's truly continuous.
Yep.
It's just an approximation.
Yeah. So a good example in my work would be like credits accumulated, right? Like generally nobody's accumulating 0 credits. Yes, it could happen. And most of the time we're looking at.
And there's no real ceiling, right?
Right.
You're going to have like 8 million credits.
122.5. Thank you.
It's close enough. That's positive infinity as far as I'm concerned.
Yes. Yes.
She has 2 PhDs. That's why.
Well, I don't yet.
She's gonna.
Yeah.
There's no jinxing involved.
All right. I'm going to hand it off to Bladimir now.
Thank you. So, next question is, in trying to predict a binary outcome, how do the outcome scales of logic, odds, and probability relate to each other? Can someone help me with this one? And I will take advantage. What is the PowerPoint? Do you close it?
I did because the
I-
equations are screwed up. Let me get the PDF out.
I wanted one slide that can help us to
You may
understand
have
this.
one slide, I
We're
promise.
pretty bad TAs.
No, you're just using my stuff, right? It's not your own
I
stuff.
have the picture here. But it's small,
I know.
think.
I'm probably gonna have no, that's example 2. Hang on, I clicked the wrong thing. Un momento, por favor. There we go. So
That's it.
I
this
think your
one.
taskbar at the top is what is also.
Thank you so much,
Yeah,
Lisa.
well, that's where all the menus are. So it's more efficient.
Yes, this is what we are looking for. So, what's the relationship between these 3 different scales?
They are all methods of explaining the likelihood of specific outcomes. So with odds, you're looking at the probability of 1 divided by the probability of 0.
Yes.
Whereas just a regular probability would be the probability of 1 divided by 1, or the probability of 1.
Yep.
And then the logit is where you then take the log of the odds and the probability.
Exactly. Yes.
So they're all explaining this likelihood somehow in slightly different ways, but convert between.
Exactly. Yes. Great. So, as Sergio said, and you can see here, for example, when we have a probability of 0.5 in terms of odds, that's 1 because it is 0.5 over 0.5. That's 1. If we take the logit of that one, that's 0. But you can see here that in terms of probability, there is a nonlinear relationship because the differences in terms of units between the logits and probabilities are nonlinear. So you can see here, for example, between positive 3 and 4, it is not the same in terms of probabilities. They are getting closer in terms of probability compared to logits. What questions do you have about these 3 scales? Because your description, Sergio, was very good. I don't have nothing to add. But what question do you have about this? Are you okay with this? People on Zoom? Sorry, let me see people on Zoom here. Shut. Okay. Okay, yes, we are right. Sorry?
What are the ranges?
Oh, to me? For them. What's the range of these different 3 scales? Someone?
Probability would be 0 to 1.
Exactly, yes.
Odds, I guess, would technically be not a number to 0.
We have one of the boundaries, it is from 0 to 1. Yes. Then is 1 to positive infinity. Yes. So that metric is skewed, and that's why we are taking the log of odds, because at the end of the day, what we want to work with is something continuous, and odds are skewed for that reason. So yes, yes, exactly. So in terms of logs, I think the logic goes from negative infinity to positive infinity. So continuous. Okay, let's go to our last question here. This is hard because it is hard to fight with people
That's
sometimes.
why I took question 1 and 2.
What do you say to reviewer 3 who insists that you need to fit a probit regression instead of a logistic regression? I have some notes, but I would like to hear some opinions. I read some comments and answers, and they were good. So please share your opinions about it, your impressions. Yes. Yes, exactly. What do you think about this one?
At first, the predicted outcomes are approximately safe
Okay.
between the probit and the logic state.
Yeah.
But
Yes.
I
Okay.
think the logic is easier to compute than the probit, and the probit it doesn't have odds ratio.
Exactly, because they are based on different things.
Yeah.
Yep. Something else? People?
I used Lisa's slide that said logit versus probit. If you need to know the difference, probably not. To answer it, mine. So I think they give you the same result as with slide, but isn't logit just used more commonly and like software has more packages to do that?
Yeah. Yes. Agree. Because at the end, using both things, the conclusions should be the same in terms of what the role of predictors in your model are. So I have some differences that we can highlight. For example, in terms of the link functions, what are the two things or two links functions that we use with each model in terms of logistic binary regression? What is the link function that we use? Logistic function. Yeah, that's the function that we use. But in the case of probit, what's the link function that we use?
You mean distribution? Is that what you're saying?
Oh yes, yes. What's based on? Yes.
Yeah, I got a slide on that too.
Yes, I'm trying to put that, but I don't know how to get there now.
Yeah, drag your mouse over to the other mouse.
If you're over here and you scroll,
Yeah, look
go the other way.
the other way.
Yeah, it's the way it's oriented. I changed it to intuitive.
I cannot. Can yes.
No, we're
because
running into
I'm
it.
trying to go there
Yeah, it's hard.
because I know that there is one
Whoa, we
slide
did
that
it.
can
Yeah.
help us.
Okay, I think there must be an edge down here. And
Wow.
so
Great. Thank you so
Okay.
much. So
Don't keep your-
here,
mouse on this screen.
yes, this one and this one. So yes, thank you, Lisa, because in the case of the logistic regression, we are assuming a logistic regression for the model scale, right?
Based on a logistic distribution.
Yes, a logistic distribution. But in the case of probit, we are using the cumulative standard normal distribution. So in some fields and in some cases, researchers can choose logistic or probit. So the takeaway is that the conclusions will be the same. So what I would say, and I took this from Microsoft Copilot, as I told you, I was trying to get some answers from IA. So the answer, and I think this is a good one. My answer would be this one. Remember that both models are valuable tools for binary classification, and the choice depends on the specific problem and data characteristics.
That is a hand wavy answer that does not help at all.
Yeah, but that's polite at least. So
My job is safe.
yeah, yes, that's for another discussion. But yeah, so what questions do you have about scales or differences between probit and logit, or how to use them? I don't think so. Considering the power of our software these days, I think that both things would be almost the same. The thing is, what do you how do you want to interpret and communicate your results? To me, that's like the big difference, because at the end, look at here. You can see that between logit and probit, there is a linear transformation of the coefficients here. So if you want to go from probit from probit to logit, you could take your coefficient estimates and multiply them by 1.7, and you will get similar results. Do you have something to add, Lisa?
Yeah. So it's a difference in scale. It's like asking, do you want your results in inches or feet, or centimeters or meters? Because these two probits are on a scale where the variance of the underlying distribution. So I wanted to say a few things about
Sorry.
that. No worries.
I thought this was going to help.
Yeah, the variance of the underlying distribution is 1 in probit. The variance of the underlying distribution is logit. But we don't have underlying. It's a fake concept. So it motivates the scale of these things to borrow those ideas, but we will never know what the underlying distribution is. We got zeros and ones. So it's literally just setting a scale for the model in which we can predict this unbounded outcome. But when you back translate, the predicted probabilities are equal to the third decimal place. So I would tell reviewer 3, they come to the same conclusions, but logits have the advantage of having an easier computation for predicted probabilities, because otherwise you have to integrate, and Nikki will be answering any questions about integration for me.
No, I won't.
Because I haven't done that since calculus my senior year of high school, and they don't have odds ratios, as you said, so it's harder to come up with an effect size measure. Now, I wouldn't tell you about probit at all, except for 2 things. Probit is ogive in IRT, and you need to know that. And number 2, if you're going to fit measurement models or structural equation models for categorical outcomes, and you do it with what's known as limited information estimation, you're stuck with probits. There is no choice for logits. And I know that that's coming, and so that's why it's here.
Great. Thank you.
So, good job, guys. Way to persevere against all the technical difficulties. Yes. Yeah, I told the other class I feel vindicated today because the TAs are experiencing the difficulty in the monitors and the Zoom and the chat and the people. So it's a working memory problem. I read a couple answers that seem to be confusing what this E is in this. So there is no E in any of our logistic regression or probit regression equations. This E refers to Y star being predicted. Y star is what statisticians call this fake underlying distribution that we don't have. So E is not real. It's just a motivation for how to scale the model using the logistic distribution or using the normal distribution. So it shouldn't change it should not change your results. Okay. So good job, guys. Any other questions or things you want to go over? Things that we can repeat? Make sure I'm still recording. It looks good to me. Okay. Okay. Then I think what we have left is the end of example 2A. Does that sound right? Sounds right to me, but I could be wrong. No, I went to close that one. Goodness gracious. It's the interaction model. That's what we have left. And if we have any extra time after that, we will dip back into ordinal and nominal, the slides that we skipped back over. So it's starting. There we go. I wish it would just trust me. Every time I open these files, it needs me to tell it I trust it again. But they're my files. All right. Remember the story here? What we're predicting in this example? The logit of applying to graduate school, which in the data were scored this way on a 0 to 2 scale that they didn't tell me what the numbers meant, so I made it up. And then I collapsed it for the purpose of having a binary example. Would you ever do this in real life? Probably not. We would never want to cut up a continuous variable or collapse categories if we don't have to, because we're losing information. We're introducing measurement error. The only situation I might do that is if only one person said vary in my whole sample. I can't really work with that. They're going to get collapsed into something that's a little more common. But this example is binary. The one that is coming for ordinal and nominal is going to use this 3 category version. So we went through descriptive statistics. We talked about bivariate measures of association last time. Remember the take home on this? What's wrong with Pearson correlations for binary data?
It's bad.
It's bad. Yeah. Basically, if the means of the 2 variables to be correlated are not both 0.5, there's no possible way the correlation can hit 1. It's going to be dampened. So it's not a good measure of association. The alternatives work with the concept of a bivariate normal distribution and include these menu options. Tetrachoric tries to tell you what the correlation must have been to figure out how many people are in each combination of the 2x2 table. Polychoric is the same idea, but for ordinal. And biserial is binary, like the tetrachoric side with continuous, and polyserial is the polychoric side with the continuous. So there's some alternatives for you in working with binary or ordinal data.
And these new ones all range between 1 and 0, and hypothetically 0 and 1 are possible.
Yeah, -1 to 1. They should.
LOL. Yeah.
Yes. Yeah. They should range the whole way. So this was the idea, is that if I have a scatter plot that looks like this for the pretend underlying continuous variables, then I can figure out roughly what proportion of my sample would be in each of these quadrants. And so the tetrachoric correlation is trying to find the correlation that would yield this balance of people that we found in our observed contingency table. That's how it works.
Explain why we are starting by calculating correlation first?
Yeah. So in most research articles, the first information that is presented either in the method section or the results is descriptive statistics. So specifically, univariate descriptive statistics would be things like means, standard deviations, proportions in each category. This was summarizing each variable in the sample. And then the next layer would be bivariate descriptive statistics, essentially, which would be measures of association. So chi-squares, if you have a table like this, you might report a chi-square value as a test of whether these things are independent. Correlations are very, very common. But most of the time when people say correlation, they're talking about Pearson correlation as a very specific kind, because that sort of came first and is the easiest to compute, but it doesn't work well for bounded data. So to the extent that you don't have a lot of variance, that limits your potential to show covariance or correlation. So these other measures would be used in place of your traditional correlation table that you might report among your variables. You could report the type of correlation, as shown in this matrix here, that is the most appropriate for the particular scales of measurement that your variables have. So this information is useful because, let me look at the values in this. Let me blow it up here, for instance. In looking at this table, it looks like people whose parents have a graduate degree are more likely to decide to go to graduate school than not. So that's what a higher value, right? So a correlation, the higher you are on X, the higher you are on Y. A negative correlation is higher on X is lower on Y. So if we put that in the context of binary, being higher means being more likely to have a 1, and being lower means more likely to have a 0. So this positive correlation, polychoric correlation of 0.38, indicates that people who are a 1 with respect to their parents having a graduate degree are more likely to be a 1 in their decision to apply. There's a positive association. But the whole purpose of my model is going to be, let's look at all 3 of these things in predicting application. So let's say that parent graduate degree ended up being non-significant in my model. That could happen, right? It could happen to the extent that the relationship that it shares with the application decision is duplicated by these other predictors, that it doesn't have a unique association. So showing bivariate associations answers the question, are these things related at all? The regression models that we're subsequently fitting is asking the question, are they still related after controlling for this other stuff? And I think those are both interesting things, because if I come to the conclusion based on my regression that, say, parent graduate degree doesn't matter, that's not really accurate. It does matter. I have evidence for that right here. It doesn't matter above and beyond these other things if it's not significant in the joint model. Does that help? Okay. Think of like the Venn diagram sort of idea, like you have your overlapping circles, and then the middle section nobody gets credit for as an individual predictor where they overlap, but it still contributes to your R-square and your model prediction. We're trying to isolate that middle portion, and like, what if we didn't look at it that way? Let's look at it just pairwise, two things at a time. What is the level of association? And then how does that change after we throw these things in as competitors to predict this outcome? Okay.
So I just started homework this morning.
Yes.
And I found that I don't really need that test to.
That's correct.
Homework, so
Yep. There are no correlation questions on your homework because I could not be assured that all of your different software packages would give you the exact same answer to 2 decimal places. That is the reason why.
Okay.
I would argue that. No, I.
Don't get me started, all right? Just don't get me started on that. But I also added this new this year, and so I had built the homework beforehand. But I'm very careful at this point, after having done this for a few years, to ask questions that I can be certain are going to replicate across packages. And whenever they don't, it's ours problem, always. SAS and Stata usually agree to like 4 decimal places. So, but great question. The why of what we're doing is arguably more important than the what. So, and you just asked a why question, so that's good. Okay, other questions or impressions. That was Cass said. She's like, what are your impressions? I'm like, that's a nicer way to say it. I am looking just at in terms of effect size for this level of sample. It's like 400 people. It will be, but I think you have to ask for p-values like separately. In this package, I don't think they give them to you. They give you standard errors, and so you could like sort of reverse engineer a p-value if you converted them back to a z-score, like the Fisher Z transformation whole thing. But the lazy answer is because the package didn't spit them out is why they're not here.
Yeah, Stata has an option that you can display like sample size and significance.
In Pearson correlations, yes, but this is an add-on package called Polycork that doesn't have them. Of course not. There are software packages that give you p-values. I know that SAS, ProcFreak, and ProcCore will give you p-values. M+ will also give you p-values if you learn how to. You will learn how to use that at the end of the semester. So you can get them. I'm just focusing on these as measures of effect size right now. Okay. Other questions? Okay. So we did the empty model. We kind of did that a lot. Do we need to do that again? Probably not. The purpose of the empty model is to make sure you know what your software is predicting. In the ordinal unit, that will be much more important. Figuring out what Y is the hardest part about analyzing ordinal data. It really is. So that one's good. How about we did main effects models? Do you want to do that again? Off section 2 of your homework. We did it in Stata before. Let's look at the R output instead. Okay. So this is an example of a logistic regression model. I am predicting the probability of applying to graduate school from my 3 predictors and looking at whether they each have significant effects uniquely after controlling for each other and in what direction. Okay. I don't care about the p-values. I want you to know what to do with the numbers, regardless of whether they're significant. Starting off on intercept. First off, what scale are we in here? Logits, odds, or probabilities? logits. So the fact that I have this negative intercept is not weird, because this is not a probability of anything. This is the logit, which is the log. Yeah? The log of the odds of the probability of a 1. Yes, that's what this is. The fact that it's negative tells me, is it closer to 0 or closer to 1? 0. What's neutral? What is a neutral logit in terms of probabilities? 0.5. 0.5 probability means just as likely to not apply as apply. The fact that this is negative means we're closer to the 0 side. So my reference person has a logit of negative 0.54, and that person is someone with a GPA of 3, whose parents did not go to grad school, and who went to a public university for undergrad. That's what 0 means in the context of this. So all of these slopes are positive. So if you want a quick and easy explanation without the numbers, what can you say? They all do what to my predicted probability? Make it go up or make it go down? Make it go up. Okay, so as these variables increase, higher values correspond to a greater probability of a 1. That's what I can say. And honestly, most result sections would stop there. You can just look at the sign. However, that's not good enough for me. I want you to know how to use the numbers. So these are slopes. A slope is always the change in y for a 1 unit change in x. That will never, ever change. The trick is putting it in context. So 0.55 is the change in logit y per unit of GPA. This one, change in logit y when going between someone whose parents didn't go to graduate school up to someone whose parents who did. It's how the 1 group differs from the 0 group, always. You have to say it that way, otherwise the direction is ambiguous as to where the difference is. A positive difference means the 1 group is higher, always. Likewise, people who went to private university are more likely to decide to go to grad school, but not significantly. So parent degree still matters independently, uniquely. GPA matters. 0.04 for a p-value, we will take that? Yeah. In your homework, I keep the alpha level at 0.05 always. You can change it on your own if you want to. You can Bonferroni correct whatever multiple comparison thing you want to. I don't care. I'm not going to get into that. Not. I have a whole rant about it, but we don't have time. All right, confidence intervals, if you want those. How do I get my effect sizes? Can I talk about variance explained very easily, concretely? Nope. What's my residual variance in this model? It's always going to be one number. It's pi squared over 3, the variance of the logistic distribution. It's 3.29. It was 3.29 in the empty model. It's still 3.29 in this model because all of these slopes are predicting the regular price. Remember that analogy? The model changes scale to increase in the amount of total variance. Like the regular price increases to make it look like a better sale to keep your buying price at the same level. So what can I do instead to convey some message of effect size for these if I can't talk about R square? Zoomers, you can play too.
What are other scales the data can use?
Yeah. How do I take these and turn them into conventionally appreciated effect sizes that I personally hate, but the rest of the world uses them, and so you're going to learn them? Odds, one more word. Yeah, ratio, there it is. Yes, a predicted outcome is in odds. The change in the predicted outcome for a 1 unit change in the predictor is in an odds ratio because there's like 2 things in the numerator, 2 things in the denominator. That's in a slide. Let me find that slide.
I think that's like stoichiometry.
What? Stoichiometry? Are you just making shit up at this point?
No, I'm pretty sure in like, remember in chem, you were like caught crossing stuff out. I think that's a helpful way to think about it.
Yeah. Yeah, this table. So the slope directly is in logits. If we exponentiate it or unlogit it, as I am prone to saying, e to the slope turns it into an odds ratio. An odds ratio is this nasty thing right here. So it's a ratio of two different sets of odds. What are the odds that you get a 1 if this is your predictor over what are the odds that you get a 1 if this lower value is your predictor, where it's a 1 unit change separating them. That's what this thing here is telling us. So odds ratios stop at 0. From 0 to 1 are all negative slopes. From 1 to positive infinity are all positive slopes. So it's weirdly asymmetric, and I don't like it. But the rest of the world uses these, and you shall learn them. This weird asymmetry is why I recoded the example data so that all the slopes would be positive, because I didn't want to deal with that. So let's get those. Skipping a few things here, backing out. In the R code, I found a function that does it called odds ratio. That seems pretty self-explanatory. It wants to give, hey, do you want a confidence interval on your odds ratios? Why not? Which one do you want? 0.95? Sure. How many digits do you want printed? 5. I don't know what this is. I think it's a different way of computing the, actually I do know what this is. We don't want to do that because it makes it so that you get different answers every time you run it. It's based on like a resampling type of approach. So note that all of these odds ratios are positive. Is that just because they are positive slopes in the first place? All of these odds ratios are positive.
Indirectly, yes, because positive slope means that we are closer to the probability of 1.
Mm-hmm. As the variable, as the predictor increases, the probability of a 1 gets closer, yes?
And so when we do the prediction for the odds ratios, we should always end up with larger than 1.
If it's a positive slope. Yeah, so the fact that these are positive does not mean these slopes are positive. The fact that they are above 1 means these slopes are positive. In your homework, there will be sections where I only give odds ratios. And if you look to find a negative sign, you're not going to find one. So it's a little bit tricky. If these were negative slopes in logits, they would be values between 0 and 1 instead. So they stop at 0. All negative slopes are fit between 0 and 1. All positive slopes are 1 to positive infinity. And I realize I'm backwards on the number line. That's because I have great difficulty in spatial reasoning and I can't turn it around. So just forgive me on that. If this function doesn't work, here's another way you can do it. Literally just be like, hey, e to that, go. So then I created a column called OR myself out of the coefficients that were saved and added confidence intervals myself. E to the that. All right. Examples of prediction, differences in logits correspond to constant differences via the slope, differences in probability do not. Okay, we did that model. We're ready for a new one. And the end of binary.
I have a question.
Hit me.
So how would you
I lost my
write
drink.
that in like your result section?
Oh.
The odds ratio. How would you make that into a result?
Have you made it to the end of the handout yet by chance?
No.
Oh, you're going to love this.
Okay. What is it down
Words.
there? Look at that.
Sample results section. All examples that I build in classes have paragraphs at the end that describe how I would write this up for publication. All of them. The way that I do it is like this. So for instance, for every unit higher GPA, the logit of applying to graduate school was higher by this logit slope, in parentheses, the standard error for it, and the odds ratio. If you have a table that has all of these results, I would not include this part because it's redundant, but at least including the coefficient makes them go to the table and be like, which one is she talking about? Okay, that row. And that's very helpful as an orienting thing. Alternatively, you could just start with odds ratios, but then you'd have to interpret them correctly. And like people are very picky about those words. I never get it right because they don't make sense to me. So I live in logit land, but this is how I would do it. This? So this is a test statistic. This is delta is the triangle. This is the difference in -2 log likelihood between a model with no predictors and a model with 3 predictors. So the 3 in parentheses refers to the degrees of freedom. And this test statistic, called a likelihood ratio test, is treated like a chi-square. So this 20 is an answer to what is the test statistic comparing this model relative to the previous one. On what degrees of freedom, meaning by how many parameters do those models differ, and then what is the exact p-value you get using the chi-square distribution. So within, let me go back for, zoom back out here, let me show you where those things are, because they show up differently across packages, of course. In Stata, that is given for you right here. It's always relative to the empty model, though. It doesn't do comparisons across alternative versions of your model, though. And the p-value is right here. In R, you have to do that manually by estimating an empty model. And then this ANOVA function, which has nothing to do with analysis of variance whatsoever, you list the model that you want to be compared with fewer parameters, the model with more, and you tell it this kind of test. And then it spits out this little table where there's your degrees of freedom, the number of parameters different, there's your test statistic, and there's the p-value that goes with it. So in terms of writing it, you would either write it like this, -2 log likelihood difference, or just chi-square. Up to you. So model comparisons relative to empty is what we're on so far. But the next one is then how do I compare across alternative versions with stuff in it? That you have to do manually. I mean, write more code. Doesn't get spit out by default. Okay, did that answer your question about results? Okay, excellent. Other things I can answer.
When reporting the results, we are not really suggesting pseudo R-square, but instead we are using
Odds ratios.
odds ratios.
Yeah, the problem is that, I mean, literally look at this. There's like 17 of them, and there's even more. Like Bladimir went and found more that he brought in a conversation. I was like, there's more? Like, how many of these do we need? So it makes me uncomfortable to be like, I like this one, and disregard the others. And I've seen these come to very different conclusions in data, like wildly different estimates. So that makes me feel squishy, which is my word for uncomfortable, and I don't do it. But particularly in medical settings, odds ratios are everything. Like they want to know the odds of dying if you have the treatment versus odds of dying if you have the control. Like that is where they come from. There's also computations called relative risk ratios that are used in that in medical settings that have to do with outcomes that don't happen very much. We're not going to do that, but that's a whole nother thing. If you take a class on categorical data analysis from like a biostat program or a stat program, they will talk about the various kinds of ratios that you can build out of a contingency table like these. But yeah, because there's too many, I'm going to do odds ratios instead. Okay, how about we do interaction terms? Guess what? It's exactly what we already did in the last unit. You're just going to do it again. You're going to keep doing it until you get it. And if you already get it and you're like, this is boring, good. Won't take you long then. And for the record, I do my own homeworks. I do actually fill in the boxes to make sure everything is coded correctly. And then I ask the TAs to do the homeworks to make sure everything is coded correctly. So I know how tedious it can be. But I would much rather have you have the feedback that you're on the right track than to turn in something that's completely wrong and not know that until it's too late. So I'm going to throw in some interaction terms to answer the question, to what extent does the effect of GPA differ by parent education and undergraduate school type. So I'm conceptualizing parent degree and private school as moderators for how having a higher GPA might matter more or less on your probability of applying to graduate school. Maybe GPA is more important in people whose parents don't have a graduate degree than people who do. Maybe GPA is more important if you went to a public university. Right? These are the types of questions known as moderation. The way that we address those questions has nothing to do with logits. It's all the same stuff you already learned. So we add in Stata first, we've got the hashtag for the two-way interactions defined on the fly. We've got them entered in here. I am going to do a comparison against the previous model. So let me point out where that showed up first, because we're going to have to do it in both R and Stata. Here. This is the previous model. This command estimates stores. Like, hey, all the stuff from this model, go save it and call it main. Just what happens in R, just it's implicit. In R, you're saving things as you go. So you have a bunch of objects that you can work with as you need to. So then in Stata, for my new interaction model, it's like, hey, go save this. Then there's a built-in command called LR test, where you say, is this one better than that one? Where it's the higher parameter model first, followed by the lower parameter. It's backwards relative to what it is in R. And so this is my omnibus test of whether the two interactions improve my model. Survey says, what do you think? Not significantly different. So here are your choices. Did I make my model not better or not worse?
No worse.
You got to vote for not worse? No, you're going to rescind your vote? Yeah, it's not better because we started with stuff, we added things. If it's not a significant difference, it means the things we added didn't help. It's not better. Not worse is if we had a whole bunch of crap, took some stuff away, and it didn't change the results, then that's not worse. Didn't need the extra stuff. Yeah. So this is what you are needing to do anytime you are comparing alternative models with different predictors as a joint test. If you want to just look at each individual interaction term, you could also do that. But this is helpful whenever the parameters that you're adding sort of fit together conceptually, such as interactions that belong to the same categorical predictor, which is what you'll have in your homework and what you had in the golf homework as well. Then I asked for predicted outcomes. I asked for simple slopes. So do you remember the rules for simple slopes? Find all the terms in the model that have it, bring them down, factor out the thing the slope is for, then you have what's left. So what I want in all four of these cases is the slope of GPA. That gets a 1. Then who do I want the slope of GPA for? The first one is for someone who has 0 values on both of my moderators, then 0, 1, then 1, 0, and then 1, 1. So there's 4 potential simple slopes this model implies. Then we can do the same thing with odds ratios and note the OR at the end here. That one converts the model estimates into odds ratios, but then in the lincoms you can do the same thing. So you can get odds ratios out of linear combinations of things, like simple slopes. In R, here is one catch that I want to point out. Whether you like it or not, R is going to reorder your fixed effects to put the interaction terms last. And why that matters is in figuring out for your simple slopes where the 0s and 1s go. I wish I could fix it. I don't know how. I've looked and I couldn't find it. So in this code, the 1 in the second spot refers to the slope of GPA. I need one of those. The 0s and 1s in the interaction term spots turn the moderators on and off for each combination of slope, like a switch, because they're binary. Okay. Coefficient time. Let's start with the slope of GPA as a thing I care about. That is no longer the slope of GPA for everybody, right? It's conditional. Who is it for, given these two interaction terms? What kind of kid? Par D means your parent has a graduate degree where no is 0.
So then it would be 4 people whose parents don't have a graduate degree.
That's right. So this simple slope, as they call it, hate that term, let's go with conditional slope, is specifically when the interacting moderators are 0. So that means the slope that's given by the model is for somebody whose parents did not go to grad school and who went to public college. Now, if your parents did go to grad school, what does that do to the slope of GPA? You have 4 choices. It made it more positive, more negative, or less negative. Less positive. Did it make it weaker or stronger? Weaker. Yes, less anything is a weaker slope. You are reducing how much GPA matters in predicting the probability of going to grad school, applying to grad school. The other interaction term does the same thing. So they're both in a less positive format. So these interaction terms are not the slopes in the alternative groups. They are the differences in slopes. So if I wanted to know what is the slope for somebody whose parents went to grad school, I start here. What was it for people who didn't? And I add that coefficient. That's what the 0s and 1s are doing. So 1.25 minus 0.84 is how I compute the predicted GPA slope for somebody whose parents went to grad school. So we've got all of those, but this is exactly the same as what we did with the standard linear model, and it will stay that way throughout the semester. The only catch is that you're talking about logit y, or it'll be log y in next month. It'll say log y for a while. So here are the results of those simple slopes. So it looks like the effective GPA is not significant within any of these subgroups, whereas it was when you put it all together. So this is more likely a power issue. You're dividing up your sample, so there's fewer people to contribute to each of the slopes. Likelihood ratio test, here's my ANOVA function to do that. So comparing the model with only main effects as the fewer nested model against the model with the 2 interaction terms. There's my test statistic. It's labeled deviance. That's your chi-square likelihood ratio test statistic. Sometimes it's called deviance in other contexts. And then here's the odds ratios that I asked for. These are all positive. Note the values for the interaction terms. Remember the interaction terms were negative? Odds ratios between 0 and 1. If you need to get odds ratios for the linear combinations, you can do that too. I did it manually by asking to exponentiate the column of coefficients and then spit it into a data frame so it prints neatly. So I will ask for linear combinations of things in your homework. You can compute those first and then get the odds ratio that corresponds with that. Here's some predictions. So you'll get to do a few of those. Type equals link, that means they're in logits. Type equals response means they're in probabilities. And anytime you talk about an interaction term, you better make a picture. So I have 2 pictures. The one on the left, the x-axis is GPA. The y-axis is predicted logits. No one on earth will know what the hell this means. Only people who like logits like me, weirdos. But I like this because you can see from these pictures, these are straight lines, okay? These are linear slopes. The effect of the predictors are linear because that's how we put them in the model. When you back translate, so if I go from the left picture to the right picture, that's inverse link. Now I'm talking about predicted probabilities. The slopes start to get a little bendy. They have to because they got to shut off at the asymptotes. So I only plotted 3 points, which is why they don't look nice, but if I had plotted more points, you'd see more of a curve. So this is kind of in the middle of the S-shaped curve where this would start leveling off as you get closer to 1. probably at like a GPA of 6 or something. And then this would level off as it gets closer to 0. So what I would give your reader is the plot on the right. But you have to be careful to understand that just because these lines are nonlinear, that's because of the transformation into probability space. It's still a linear relationship between GPA and the outcome. That's it. And here's some words.
Lisa, could you just talk like big picture wise?
Yes.
Like what your result section is doing. Like this paragraph is communicating X, Y, Z. This paragraph, like.
Yep. So all of my results sections have the same structure, and it's so formulaic that I wrote a computer package to do it in homework. Okay, that's how formulaic this stuff is. The first paragraph is often at the end of the method section under like analytic strategy or something like that. So I prefer it in the beginning of the results. It's what are you going to do, broadly speaking? Like these are my variables. This is the scale they're on. I might talk about centering here. I estimated general linear models using maximum likelihood. So that's the type of model. And then more specifically, the outcome is predicted with the logit link and a conditional Bernoulli distribution, i.e. logistic regressions, right? So if between the combination of those words, somebody will know at least some part of the sentence. And then the GPA predictor was centered. Effect sizes are providing using odds ratios in which I describe how to interpret these damn things because I don't expect people to know that. And then how did I do nested model comparisons? I did likelihood ratio tests. So these are sort of general process. This is how I did it. And then we get into this model revealed this model revealed that, kinds of things. And typically for non-significant results, you would just say they're non-significant and move on, which is why I did that. Plus this handout is already 11 pages long. And, you know, we're only in example 2. All right, does that help? Okay, that's usually how I do it. So where we're headed is categorical data next, starting on Thursday, ordinal and nominal. Guess what? You already know how to do it. The catch is that these models are going to divide up the possible categories into a series of binary models, and each one of those is going to be predicted with a logit. How the categories get divided up is the difference between ordinal and nominal. But they're all based on logits, which is why we got to make friends with them. All right? All right. Thanks for being here. Let me know if you need anything. Happy homeworking, and I hope to see you on Thursday. Bye for now. Bye, Zoomers.